here we're going to look at simplifying, but instead of square roots, we have a fifth root, a third root, and a fourth root. It works the exact same way as square roots when you say, hey, do I have any factors that are perfect squares? Except here, you want to say, do I have any factors that are perfect fifths? Now, perfect squares we're probably more familiar with off the top of our head, like 9, 16, etc., etc. So I would say, somewhere in my notes, I would make myself a little list of perfect cubes, perfect fourth powers, perfect fifth powers. And you notice one nice thing about it is, like, let's look at the fifth power specifically. See how they get really big really fast? So you do have less of them to try. Like when I look at 96, 243 is already too big to go into 96, so I really only have to try 32. So I look at 96 and say, well, hey, 96 is 32 times 3. So I can split this up as a perfect fifth power, fifth root, and then whatever's left over. So 32 times 3 gives me 96. So it'll be weird at first because you want to keep using 9, 16, 25 perfect squares. You have to think of perfect fifth powers. And so the fifth root of 32 is 2, like we had on our little sheet. That's why it's good to have the sheet to kind of reference. So 2 times fifth root of 3 is the same as the fifth root of 96. All right, so then for third root of 81. So if I look at my perfect cubes list, I have 8, 27, 64, and so if I'm thinking about those, 64 is already too big to go into 81, and then does 27 go into 81? And then you could try them on your calculator. You don't have to know all of these off the top of your head, but 27 times 3 is the same as 81. So third root of 27, 3 times 3 times 3 gives you 27, or you can reference that off your list. So 3 times the third root of 3 is a simplified version of third root of 81. All right, then last one, fourth root of 96. I look at my fourth roots. I have 16, 81, 256. So 16 is really our only option here. Does 16 go into 96? So the other ones are already too big to be a factor of 96. So 16 goes into 96. I could think of this as the fourth root of 16 times the fourth root of 6. And so fourth root of 16 is 2 times itself 4 times, so 2 times whatever was left over, which is the fourth root of 6. So this and this should be the same. It's just a simplified version. So it's helpful to have the list of perfect third, fourth, fifth powers, just because you're not as familiar with them as square roots. They don't jump out into your head, but the good news is they're shorter lists than perfect squares.